Welcome dear viewers, on the Abu Bakr Yendan channel. Ramadan Kareem. We will talk about the universe and the solar system. Let's start this journey. The universe and the solar system. The universe is all of space and time and their contents, including planets, stars, galaxies, and all other forms of matter and energy. While the spatial size of the entire universe is unknown, it is possible to measure the size of the observable universe, which is currently estimated to be 93 billion light-years in diameter. In various multiverse hypotheses, a universe is one of many causally disconnected constituent parts of a larger multiverse, which itself comprises all of space and time and its contents. As a consequence, the universe and the multiverse are synonymous in such theories. Our solar system features 8 planets, seen in this artist's diagram. Although there is some debate within the science community as to whether Pluto should be classified as a planet or a dwarf planet, the International Astronomical Union has decided on the term Plutoid as a name for dwarf planets like Pluto. This representation is intentionally fanciful, as the planets are depicted far closer together than they are in reality. Similarly, the body's relative sizes are inaccurate. This is done for the purpose of being able to depict the solar system and still represent the bodies with some detail. This illustration shows the approximate sizes of the planets relative to each other. Outward from the Sun, the planets are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, followed by the dwarf planet Pluto. Jupiter's diameter is about 11 times that of the Earth's, and the Sun's diameter is about 10 times Jupiter's. If you've ever dreamed of time traveling, just look out at the night sky. The glimmers you see are really snapshots of the distant past. That's because those stars, planets, and galaxies are so far away that the light from even the closest ones can take tens of thousands of years to reach Earth. The universe is undoubtedly a big place. But just how big is it? That may be something that we actually never know. Sarah Gallagher, an astrophysicist at Western University in Ontario, Canada, told Live Science. The size of the universe is one of the fundamental questions of astrophysics. It also might be impossible to answer. But that doesn't stop scientists from trying. The closer an object is in the universe, the easier its distance is to measure, Gallagher said. The Sun? Piece of cake. The Moon? Even easier. All scientists have to do is shine a beam of light upward and measure the amount of time it takes for that beam to bounce off the Moon's surface and back down to Earth. But the most distant objects in our galaxy are trickier, Gallagher said. After all, reaching them would take a very strong beam of light. And even if we had the technological capabilities to shine a light that far, who has thousands of years to wait around for the beam to bounce off the universe's distant exoplanets and return back to us? Scientists have a few tricks up their sleeves for dealing with the farthest objects in the universe. Stars change color as they age, and based on that color, scientists can estimate how much energy and light those stars give off. Two stars that have the same energy and brightness aren't going to appear the same from Earth if one of those stars is much farther away. The farther one will naturally appear dimmer. Scientists can compare a star's actual brightness with what we see from Earth and use that difference to calculate how far away the star is, Gallagher said. The universe is cold and clumpy today, but it's also expanding and gravitating. When we look to greater and greater distances, we see things as they were not only far away, but also back in time, owing to the finite speed of light. The more distant universe is less clumpy and more uniform, having had less time to form larger, more complicated structures that require more time for gravity's effects to take place. The early, distant universe was also hotter. The expanding universe causes all the light that travels through the universe to stretch in wavelength. As the wavelength stretches, it loses energy, becoming cooler. This means the universe was hotter in the distant past, a fact we've confirmed through observations of distant features in the universe. In 2013, the European Space Agency's Planck space mission released the most accurate and detailed map of the universe's oldest light. The map revealed that the universe is 13.8 billion years old. Planck calculated the age by studying the cosmic microwave background. The cosmic microwave background light is a traveler from far away and long ago, Charles Lawrence, the U.S. project scientist for the mission at NASA's Jet Propulsion Laboratory in Pasadena, California, said in a statement. When it arrives, it tells us about the whole history of our universe. Because of the connection between distance and the speed of light, this means scientists can look at a region of space that lies 13.8 billion light-years away. Like a ship in the empty ocean, astronomers on Earth can turn their telescopes to peer 13.8 billion light-years in every direction, which puts Earth inside of an observable sphere with a radius of 13.8 billion light-years. The word observable is key. The sphere limits what scientists can see but not what is there. But though the sphere appears almost 28 billion light-years in diameter, it is far larger. Scientists know that the universe is expanding. Thus, while scientists might see a spot that lay 13.8 billion light-years from Earth at the time of the Big Bang, the universe has continued to expand over its lifetime. If inflation occurred at a constant rate through the life of the universe, that same spot is 46 billion light-years away today, making the diameter of the observable universe a sphere around 92 billion light-years. You might think of the universe as infinite, and quite honestly, it might truly be infinite, but we don't think we'll ever know for sure. Thanks to the Big Bang, the fact that the universe had a birthday, or that we can only go back a finite amount of time, and the fact that the speed of light is finite, we're limited in how much of the universe we can see. By time you get to today, the observable universe, at 13.8 billion years old, extends for 46.1 billion light-years in all directions from us. Thanks for watching. Don't forget to press the like button and subscribe to the channel. Abu Bakr Yendin channel.